Hello guys, welcome to Yebo Tutor Livestream Help. I hope you're all doing good on this beautiful day and I hope you enjoyed your day at class. So just give you a little brief whilst waiting for others to join in. So Yebo Tutor is a live stream platform which is there to assist and offer extra lessons for free to all the matriculants which will be writing this year and also grade 11. So if you have your friends which you know, please do share with them. And if it's your first time to listen to us, don't forget to subscribe on our YouTube page and follow us on our Facebook, which is Yebo Tutor NMU. In the description of this video, there is a link to our WhatsApp group, so you can contact us anytime, anywhere, and in real time as well. If you have any question, you can ask us on our WhatsApp platform. We will definitely share the workbook of today after we are done with this tutorial. Feel free to chat on the WhatsApp group or you can type on the comment section so that we can assist each other. The main goal is for us to be interacting with each other and assisting each other as much as we can. Okay, now let's hit and do what we are supposed to do today. So on our first term syllabus, we cover number patterns. We also cover analytical geometry. We also cover a lot of number of topics. We have calculus as well. And number of patterns is like 25 marks in your paper one for your June as well as your final and trial exam. So today we'll be starting with your number patterns, which is the first topic which you'll be doing. And I believe that you are doing number patterns even right now in your classes. So I'm just gonna do like a small summary. Then after that, we can look at the questions from the previous question paper. Then we can work on it, and we believe that by the end of this session, it will be able to help you to understand number patterns in more depth, and you'll be able to apply when you are writing your test, when you are having your assignment. I know in first term there's an assignment which is approximately 50 marks, so you must be able to know and apply or the concept of number patterns. All right, let's get down to the business of today. So on number patterns, what is so crucial or what is so important is for you to be able to understand that on number patterns, we are dealing with the sequences which we have been definitely learning from grade 10 and grade 11. But now in grade 12, they will be more advanced because now they will introduce you to what we call series. So what is so crucial and so important is for you to understand few things, which is number one. I always tell you must be able to know your general formula. You must be able to calculate the Tn. We also should be able to calculate, or let me just say should be able to write the sigma notation. So on number patterns, we were taught that in grade 11 we have the arithmetic pattern, which is also AP arithmetic pattern, which has a general formula which is Tn is equal to A plus multiply by D. Okay, what is A? A will be your first term in the sequence. What is your D? Your D will be the common difference. So someone will ask me, how will you be able to see that this is a arithmetic pattern or arithmetic sequence? So what do we look at first? We look at the difference. So if the first difference is the same, that's definitely an arithmetic sequence. So e.g., if you are given 2, 4, 6, 8, etc., etc., so we can see that 2, 4 minus 2, it's 2. 6 minus 4 is equal to 2. Then 8 minus 6 is also 2. So we can see that we have the first constant difference. So the moment we see that the first constant difference is the same, then automatically we know that it is a arithmetic sequence. So for the fact that we already know how to do the general term, because the value of a, we know it, that it is the first term of the sequence. So in this case, it's gonna be 2. So we're gonna have our 2. And just do this. Uh, yes. So our first term in this case was 2. So we have 2 plus n minus 1. And our common difference, we said it's 2. How do you calculate the common difference? D is equal to term 2 minus term 1. Or someone can say T3 minus T2. Or someone can say T5 minus T4. So it just depends on which values you have in your sequence. So in this instance, you can say that 4 minus 2, then we get our 2. So there will be 2. Then we have 2 plus 2n minus 2. Then after that, you can see that we will have our t n to be equal to 2n. So our general term of this instance will be 2n. Just like that, that one is so easy. Then now in grade 11, we were introduced to something which is a bit difficult, which we call quadratic sequence. So we were introduced to quadratic sequence in grade 12. So what is important in quadratic sequence is to understand just only 3 things, I think. Yes, quadratic sequence. Okay. So the first thing which you have to understand on quadratic sequence is that we have our general formula again, which is Tn is equal to a n squared plus bn plus c. The problem now begins when now we must be able to determine the value of A, the value of B, and the value of C. That's easy. Now, how do we find the value of A? We know that 2A is equal to D. What is D? D now in this instance is no longer the first difference, but it is the second common difference. Now that is what make a quadratic pattern or sequence so unique, because now it has the second common difference. So now in order for us to calculate the value of a in this general formula, we say 2a is equal to d, then we make a the subject of the formula, then it will be now d over 2. Now, in order for us to find b, it's easy. It's just 3a plus b is equal to t2 minus t1. So t2 is representing term number 2 and t1 is illustrating term number 1. So you subtract t2 minus t1 so that you can get the value of b. Now you make b the subject of the formula, then b will be equal to t2 minus t1 minus 3a. What is your a is the value which you have calculated here initially. So everything now will be now easy because you have already calculated a lot of stuff. Then after that, you get your value of b. Then after you know your value of b, now what is left for you to do is only for you to be able to know or to be able to calculate the value of c, sorry. And how do you calculate the value of c? A plus b plus c is equal to t1. So the value of a, we have already calculated it. The value of b, we calculated it here. Then now we just make c the subject of the formula, because definitely we know that t1 is already in the equation which we have. Then after that, you can now definitely have our general formula, which is tn is equal to an squared plus bn plus c. This is how you calculate the value of a. This is how you calculate the value of b. And this is how you calculate the value of c. Then after that, you are happy, you get your 4 marks. The nice thing about the quadratic sequence is that you get 4 full marks just to be able to determine the general formula. Now, to move forward from this part now, which we are doing right now, in order for us to move on this part, it's quite easy. Now, we must now know the third one, which is called the, which you'll be introduced right now in grade 12, maybe if you have not yet been introduced to it. This one now, it has the constant ratio. The arithmetic sequence, it has a constant first difference. Then the quadratic sequence, it has its second constant difference. Then the third one, it has a constant ratio, which means the value of r is always the same. And this sequence is called the geometric sequence. And the general term or the general formula is Tn is equal to A times Rn minus 1. This is the formula for the general term for a geometric sequence. So what is A? A is the first term in the sequence and our R is the constant ratio. So e.g., we are given 3 is to 6 is to 12. I hope everything will be good. Yes. So in order for us to calculate the value of R, R will be equal to T2 divided by T1, which is equal to T3 divided by T2, which is also equal to T4 divided by T3, and etc. So in this instance, we have our term 2 to be 6. So 6 divided by 3 is going to give us 2. Then 12 divided by 6 is also going to give us 2. So definitely now we can see that our constant ratio will be equal to 2. So the value of r will be equal to 2. So the moment we see that this has a constant ratio, then automatically that's a geometric sequence. So those are the three sequences which were introduced in grade 11 and 12 as well. Now, these sequences, they become a bit more tricky when they introduce you to sum, okay, to the summation of this. Now that's where sigma is introduced as well. So in arithmetic series now, a series is like a summation of everything. So for instance, if we had 1 is to 3 is to 5 is to 7, in a series we will now have 1 plus 3 plus 5 plus 7. Okay, so now that's the difference between a sequence and a series. So in a series we are now adding what we had in a sequence, just like uzalo or any soapy. We know that today they end here, tomorrow they are starting from where they end. So that's what we do now. So we start here where we finished yesterday, then we continue. If initially on the sequence we had 1 is to 3 is to 5, so in the series it's going to be 1 plus 3 plus 5 plus 7. Then how do you calculate that? Now we have our Sn to be equal to n over 2, 2a plus n minus 1 multiplied by d, when n is the total number of terms in the sequence. So this is just great because if you understand your sequences, you'll be able to calculate so properly on your series. So this is what is so crucial about the arithmetic series. So you just only have to know that Sn is equal to n over 2, 2a plus n minus 1 multiplied by d. Now, if we are given a geometric series, just as a arithmetic series, it's not going to be hard because now we know that it's a summation of all the terms which are in the sequence. So for instance, if we are given 3 is to 6 is to 12 is to 24, so now we know that in our series it's going to be 3 plus 6 plus 12 plus 24. So in order for us now to know, this is what is important. In order for us now to know how do we calculate the total sum of all the numbers in the series which we have, now we use a different formula. So which is Sn is equal to a r to the power n minus 1 over r minus 1. Then after that we can get our summation. So this is like a small overview which I had, guys, for you. So now let's now look at the question which I have prepared for you guys. So other things which I didn't tackle, if we encounter them during the questions, then definitely we'll attack them, then we try to solve them as much as we can. Now, this is like a Gauteng paper which was written last year. So we are given on question number 2. Let's use a different pen. Okay, so we are doing question number 2. So earlier we still remember when we started, we say that number patterns have approximately uh 25 marks. Yes, 25 marks. Now let's see how do you get that 25 marks. Now we are given the first four terms of a quadratic pattern are 1 is to 9 is to 25 is to 49. Okay, great. Now determine or write down the value of the fifth term. This is now the greatest thing. Sorry. So in order for you to understand maths, what is crucial and so important is for you to understand that it is very, very easy for you to understand what is needed by the lecture. So what is important is to have the conceptual line mindset that if you are given this statement, the first four terms of a quadratic pattern, full stop. What is a quadratic pattern? According to the overview which we did, we say that a quadratic pattern, it has a second constant difference, and we can calculate the general formula using Tn is equal to an squared plus bn plus c. Now we have already unpacked what we have been asked. Now let's calculate, let's see what do they want. First question on 2.1.1, they say calculate the fifth term. That's easy. Let's do it together. Let's do it together. So here we are. Right. 1 is to 9 is to 25 is to 49. So on 2.1.1 we want the fifth term. No, let's go. Let's find the first difference first. 9 minus 1 is 8. 25 minus 9, that will give us 25 minus 9. Someone write something in the chat. Someone write something in the chat so that you can see that we are moving together. Someone write something in the chat as well or in the group. So 25 minus 9 is going to give us 16. Then 49 minus 25 is going to give us, that will be 9, 5, 4, 2. That will be 24. Now we are hanging in here. Now let's look at what is our constant second difference. Now, because this is the first difference, now let's look at the second difference. So when we say 16 minus 8, we get 8. 24 minus 16, we get 8 as well. So 8 is our second constant difference. So the fact that now we know the second constant difference, which means also here we're going to have also 8. Also here we also going to have 8. So in order for us now to get the difference here, now we just say 24 plus 8, then we get our 32 here, then 49 plus 32, that will give us 1, 2, then we'll get 81. So the T5 term which we want is going to be 81. So our T5 in this instance is going to be 81. Let me just repeat, how do we find it? We start by finding the first constant difference. After that, we look at the second constant difference. Why do we look for the second constant difference? Because we know for sure that this is a quadratic form pattern. So since it's a quadratic pattern, definitely it has a second constant difference. So we were able to see that it has the second constant difference. So which means even in other terms which are following, they still have the same common second difference, which is 8. So since we finished here at 24, now we say 24 plus 8 so that we can get this 32. Bear in mind, if we say 32 minus 24, we are going to get 8, which is still the second common difference. Then also here, if we say 32 plus 8 is going to be 40. If maybe they say the next two terms, so if now it's 40, 81 plus 40, that will be 121. Then after that, you get your T5 as well as your T6. So that's how you can be able to calculate the next following terms in a quadratic number pattern. Now let's go to 2.1.2. Let's see what do they want. Okay, now on 2.1.2, the question goes as show that the nth of this sequence can be written as 2n minus 1 all squared. Great. So in other words, show that the nth term of this sequence. So in other words, they want you to determine or they want you to calculate the general term of the quadratic number pattern. So as we have already highlighted on our small overview, we say that in order for us to get the general term of a quadratic number pattern, how do we do that? We know that Tn is equal to a n squared plus bn plus c. Now, how do we find a first? So we have our second constant difference, which is 8. So 2a is equal to d, where a is the second constant difference. So it's going to be 2a is equal to 8. Then we solve for a. This is now simple algebra. Then you get your a to be equal to 4. Now we have the value of a. How do we get the value of b? The value of b, we know it's 3a plus b is equal to t2 minus t1. What is our a? Our a was 4 plus b is equal to, what is t2 minus t1? This is 9 minus 1. Then we get 8. So it's going to be equal to 8. So our value of b will be 8 minus 12. Then our b will be equal to negative 4. Now we want the value of c. A plus b plus c is equal to t1. What was our a? It's 4. What is our b? It's negative 4. Let's just say plus, then we put that negative in brackets. Plus c is equal to, what is our t1? Our t1, which is the term number 1, it's 1. So we write down our 1 there. Then our c will be equal to 1. Then after that, now we have the value of c, we have the value of b, we have the value of a. Now we can just put the values into the general equation or general formula or general term of a quadratic number pattern, which says Tn is equal to n squared plus bn plus c. Just like that, we are now just substituting. Let's just substitute first so that we can get the values as well. So Tn now will be equal to, our a was 4n squared minus 4b, 4n plus 1. Now this is what we have. But they said show that the nth term will be Tn is equal to 2n minus 1 all squared. So we can definitely see that this is like a quadratic equation, or like it's just like a trinomial which we can factorize. So this can be Tn is equal to, since this is our c is 1, so this can be 2n, and also it can be 2n. If we have minus 1 here, and if we have minus 1 here, that should definitely give us this. Or if you are not good in finding the factors of a trinomial, please use your quadratic equation, or the which say the quadratic formula, sorry, which says x is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a, so that you can be able to get the two factors. So since I was able to do using the factor format, I was able to see that 2n minus 1 and multiplied by 2n minus 1 is going to give us this trinomial which is here. So definitely, since the brackets are the same, so you can just square both to be equal to each other. So definitely we have shown that Tn is 2n minus 1. Then you get your full 5 marks. Just to go over it again, so the first thing which we did is they said show that the nth term is. So what do we know about the nth term? We know that Tn of a quadratic number pattern is equal to an squared plus bn plus c. Now we must be able to find the value of a. And how do we find the value of a? 2a is equal to d. What is your d? Your d is your second common difference. And now we know that our value of a is 4 after we have done our small algebra. Now we substitute in this nice equation which says 3a plus b is equal to t2 minus t1. Then after that, we substitute the value of a which we have found earlier on. Then now we can get our value of b to be negative 4. Then we get another mark, another mark, another mark. Now we are on 3 marks. Now in order for us to get the value of c, a plus b plus c is equal to t1. Then we substitute here. So we had our a to be 4. Then we have our b to be negative 4. So 4 minus 4 is just 0. Then our c now is equal to 1. Then after that, now we already have 4 marks, but now we must write it as a general formula. So when we write it as a general formula, our Tn now will be equal to 4n squared minus 4n plus 1. Then after that, we can see that there is progress. But this is not what we have been asked. So we were asked to show that the Tnth formula is equal to 2n minus 1 all squared. So since now we are here, this is a quadratic sequence, so we know that we can just treat it as a quadratic equation, then we can get our correct answer just like that. Now after that, Tn is equal to 2n minus 1 multiplied by 2n minus 1. If you don't know how to find factors, please look at the videos. Also, we have a video on how to solve for x that will be able to assist you in the process. Now let's move forward to the next question. Let's move forward to the next question. If you have any question, please don't hesitate to ask. Please don't hesitate to ask. Okay, great. Show, oh no, sorry, write which term of the sequence will be equal to 10,201. That one is already easy already. Why is it easy? Because already we have already calculated the Tn. So our Tn is equal to 2n minus 1 all squared. But now they said that which term of the sequence will be equal to 10,201. So definitely they've already given us Tn to be 10,201. Now we just have to calculate the value of n. But bear in mind that initially we had our 4n squared minus 4n plus 1. Then we can definitely solve it using this method. Or you can just like use the old way and just use your sets. Then you can be able to still get the same answer. But I'll just do two options. This is option A. Then after that, 0 is equal to 4n squared minus 4n plus 1 minus 10,201. Then 0 is equal to 4n squared minus 4n minus 10,200. Now we can use our quadratic equation, which says that our quadratic formula, sorry, which says that x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Now we are not dealing with x, we are dealing with n, so we will just say n is equal to negative. We know that this is our value of a, this is b, and this is c. So it's going to be negative of negative 4 plus or minus square root of negative 4 all squared minus 4a c, which is negative 10,200 divided by 2 times 4. Now we can use our Casio calculator to be able to find the values. So in grade 12, we usually use our Casio calculator so that we can find the values. So now we can press our calculator, as I'm pressing mine as well. So my first n value, let's use our calculators. Negative of negative 4 plus square root 4 squared plus 4a c divided by 2a. So I have n is equal to 51 or n is equal to negative 50. And definitely, of course, we can never say n is equal to negative 50 because it's supposed to be a natural positive number. So definitely our n will be equal to 51. So which term in the sequence will we have 10,201? It will be T51. Okay, so if maybe you want to prove this, you can just say T51. For instance, Tn is equal to 2n minus 1 all squared. Then now T51 will be equal to 2 times 51 minus 1. Then we square everything. Then definitely gonna get the same answer to 10,201. So this is how you solve this kind of a problem. So what was important on this question was just to be able to conceptualize the question, understand what the question wants. Just like that, then you get your full marks. Let's do the following question as well, which is I feel like it's gonna be our last question today. Today we're just like opening and just doing some few things, few channels. Next week I'm hoping to do more and more and more so that we can assist each other. So let's go. Let's get it. Let's get it. Let's get it. So now on 2.2, the first 24 terms of an arithmetic sequence are 35, 42 plus 49 plus, then we are given the last term to be 196. Calculate the sum of all the natural numbers from 35 to 196 that are not divisible by 7. That is where we find a tricky situation now, guys. It's now a bit tricky because now bear in mind that we are given numbers which are multiples of 7, but now we should calculate the sum of all the natural numbers that are not divisible by 7. So how can we do that, guys? How can we do that, guys? Talk to me, guys, in the channel. Talk to me, guys, in the group. Talk to me. Talk to me. I'm listening. Talk to me, guys. Okay, let's do it. Let's do it then. So how do we do this? So what I would advise is that we start by calculating the sum of all the natural numbers which we have in this instance or in this question. So what is the sum of all the natural numbers? So let's go. So we were given 35 is plus 42 plus 49 plus, then we have 196 to be our last term. So this can be quite great because now we just know that definitely we use the formula Sn is equal to n over 2a plus the last term. What is the number of n terms which will be there? There will be 24. So it will be S24 is equal to 24 over 2. What is our A? Our A is 35. What is our last term? Our last term is 196. Sorry. Then after that, we can use our calculator. 24 divided by 2, that's 48. Then 35 plus 196 multiplied by that 48, that will be 2000. No, 24 divided by 2, sorry, it's not 48, it's 12. So 12 times 35 plus 196, that will be 2772. Okay. Then this is the sum of all the numbers which are divisible by 7. Now we want the numbers which are not divisible by 7. So what do? N would now be equal to 196 minus 34. Then we will get our 160 or 162. Okay, because definitely we can see 6 minus 4 is 2, 9 minus 3 is 6. That's why we have our 162. So now we can see that now the number of terms which will be not divisible by 7, there will be 62 in all the numbers which we have in the sequence. So now Sn will be equal to A over 1, N over 2, sorry, then A plus L. Okay, so now it's going to be 162 divided by 2. Then now we have our A to be 35 plus 196. Sorry, our last term is 196, yes. Then now we use our calculator. 2 into 162, that will be 81 times 35 plus 196 with our calculators. Then we get 18,711. Then now, in order for us to get, then therefore, to get numbers, or let's just say to get the sum of numbers not divisible by 7. What do we do now? We just subtract the difference. So it's going to be 18,711 minus 2,772. Then we use our calculator. That would be 18,711 minus 2,772. Then we get our answer to be 18,711 minus 2,772. Then we get our answer to be 15,039. Okay, from my calculator. So this last question was quite intensive. It wanted us to think outside the box. So today, guys, I had a much in mind, but I wanted us just to start out and just start preparing now and start getting our work and our minds to work fast and efficient. Bear in mind that every moment and every time counts. So we should push and push and push and push hard. Please share with friends. Please share with family. If they are doing great health, let them know that we are here for them for free. You just have to tune in on the YouTube platform. Then after that, everything else you will receive it for free. Don't forget to like, don't forget to comment, don't forget to share. Till we meet again during this week, I hope there will be a physical class with Dr. James for physics. Please also do tune in and hear from Dr. James. It will be great and you won't regret it. Have a great evening. Good night.